Well, hello everyone. I'm Harry Ward. I'm with Harken-Reidar. We're the leading reseller for SiteOps. The software is developed by Blue Ridge Analytics out of North Carolina. This is cloud-based software. You can access the software and your data anywhere where you have an internet connection. The software can also run on any PC product or Apple product, Mac Airs, Apple Macs, Airs, things like that. Essentially, any device that can load Java can run the SiteOps software. Like I say, this is all cloud-based software. It runs on dynamic objects. You can preload constraints into the software, and it uses those constraints to automatically design your site. This sounds too good to be true, but you've got to see it in action, and that's what we're going to do right now. We'll run through a little project design. We'll start with nothing, and we'll design a project in a few minutes right in front of your eyes. I'm on the home screen here right now. Anybody that logs in, if you're a client, then your logo will appear at the top of the screen. As you can see, mine is here. All reports, login screens, and websites will have your personal logo at the top. It's hard even to tell that you're in the SiteOps software. So it kind of looks like something you've integrated in together yourself. We're on the main screen right now, and what we're going to do is jump into a project and just get going on this. So I'm going to administer projects. Here are a listing of your projects, and I'm going to grab the Warrenton property right here. This is a parcel in Warrenton, Virginia. It's available. And we have a hypothetical an engineering project to run right here in front of you. And that's going to be a site feasibility analysis. We want to recommend whether or not to purchase the site for our client and give them some ideas of what they might do with the site. We want construction costs, and of course you can even estimate the retail value of your project. Now everything starts with the default properties. These are preloaded into every project, and you can alter them as you need to. You can also generate geographic templates or client-based templates with all the settings preset for that area or for that client. There are several constraints in here that the engineer would use. These are the same numbers an engineer would use if they're designing the site by hand. These parameters come preloaded, but they can be changed. So if you have a parking stall, the width of it's 9 feet, maybe the length is 18, you can alter it here, and this will seed the parking lots that you're about to place into the site. Now you're not locked into this. Every parking lot can have its own parameters. These are just the starting values. So you have all your engineering constraints sitting here at the top. These are your layout, your horizontal constraints, geometry constraints. They can all be preloaded and modified. If you keep scrolling on down, you're going to notice that there are grading constraints. And so just for instance, I'll point 1 or 2 out right here. If you generate a parking lot, the maximum slope on that parking lot shall be 4%. The minimum shall be 1. So your parking lot shall be between 1 and 4%. If you'd like, you can always change these values, maybe go up to 5% depending on what your county allows. If you keep coming on down these constraints here, at some point you're going to notice that we have stormwater constraints as well. And the idea of being able to do conceptual design, which includes your horizontal layout, your vertical layout, and your storm drainage, is unthinkable. There's nothing out there that can do these types of things. Look at this rainfall intensity, for instance. This indicates that we can do the drainage because the software uses the rational method to compute your ponds and your storm sewers and sizes and things like that. So Q equals CIA. This is the I, this is your rainfall intensity, and you can change it based on your geographical location. The area in that calculation is on the area that you draw, and every area that you draw has runoff coefficients. So that you can see right here, stormwater, and if we keep coming on down, now you're going to notice unit costs for all the materials on your project. These unit costs come pre-populated, and they emanate from the RS means national averages. They're updated annually, but you can make changes here based on your local conditions, your contractor's prices, or your client's requests. You save these off, any number of these, and then you can use them in your project. All I would do is grab which template I want and then import that template. Let's go ahead and jump into the base map. this is where the CAD system is. These records right here all indicate potential milestones in the project. And so the way I usually run this, when I hit a milestone, I'll save that version, and then I'll keep going with continuing work in a new version, just in case the client ever says, oh, I don't like the direction this project's going in, let's go back to last Wednesday. Well, then I have last Wednesday sitting right here. So all versioning is supported. You also have the authority to add users at any time and give them different privileges to maybe work on the project but not save it. Perhaps you're letting a client use the software to second guess you. So they can move things around, verify your results, and see why you might make recommendations, and perhaps then don't let them save the file. I'm going to go ahead and jump into what we call the beginning here. I'm going to start right at the beginning of the project, and we're going to lay it out live right now. I'm going to stretch that screen up a little bit. Again, this black area, this is your CAD system. And I have a number of user preferences where I can change cursors and background colors and things like that. It's downloading this data right now from the cloud. As soon as preferences are applied, I'm ready to go to work. And you see, I've already started with an ortho photo. And if I turn the layers on and look for the contour existing grade, you'll see I've also got topography. And so your first question might be, well, Harry, how did you get this far? Okay, so here's a couple of ways that you can start a project. Number one, you can go up here and create an empty project, and you'll get a 1 million square foot piece of property, insert a picture, and then start digitizing on it. This is a very traditional method that we've used in CAD systems for many years. Unfortunately, with a CAD system, you have to develop all the objects in 2 and 3 dimensions, and that's what takes all the time and eats up the budget. But you could do it. The second approach to building your project up would be to import data from a CAD file. And if we look over here at the Browse command, you'll see that it supports AutoCAD files, LandXML, spreadsheets, and Esri shape files. So if I have anything already pre-drawn, then I don't have to draw it again. I'm just going to suck it into the SiteOps and declare what the objects mean: parking lot, buildings, roads, things like that. So that's the second method, to bring in any data that you have already drawn. The method that I used was this one here, geolocate site. And so I'm going to go ahead and launch it. And what you'll notice is a Google interface comes up. Everybody knows how to use Google. And in this case here, I've got Warrenton. I've located the property. And if I turn on the satellite map, you'll notice that my ortho photo is coming in. At that point, I simply hit select location, which of course I've already done. So I'm going to cancel this. And when I return back to that base map, it's waiting for the data right now, which I already have. So I'm going to cancel that. And that's how I started the project. I was able to geolocate the site, which means I'm in the correct NAD 83 location for Warrenton, Virginia. And you'll see the evidence of that at the bottom of the screen where the coordinates are listed. 11 million, 7 million is in NAD 83 vicinity for Warrenton, Virginia. Now, I don't have I didn't obtain a boundary from this download. So once I geolocated the site, then I can go to USGS or Esri, and I can bring in imagery or topography from these agencies. I also have the ability to import topography and photos from SketchUp at no cost at all. This is a free service. So when I used the import topo USGS, I went ahead and took my photo from Esri. I took the topo from the USGS, and I got a rectangular boundary of the photograph. Okay. Now at that point, I'm going to go ahead and estimate where the property is that I'm investigating. And so I simply draw a polyline-oriented feature and then convert that into a property and tell the software to use it. And that's exactly how I prepared this. Now, what I did was I just basically traced along the tree line. I'm watching my roads and things like that. And here I'm a little liberal, so I'm going to pull this back and clear that roadway. Okay, so right there, and maybe the property actually goes here just based on the tree line that I'm seeing and the roadway, right-of-way, and things like that. Okay, so I have the underlying image. I sketch in the boundary that I think is appropriate. And again, a lot of times you can use tree lines to indicate where properties are, because the idea here is that I want to go ahead and conceptually lay out this site, obtain construction cost, and then maybe estimate the retail value of what this thing might generate. Once I develop this concept plan for the client, then because of the speed and the expeditious manner in which I can develop this work, once a client sees what I can produce, then I'm going to ask the client, how can you not use me on this? And this is how people obtain new clients. Their work at the conceptual level and the feasibility stage of projects will blow away anything any other engineering firm can do, and I don't care what CAD system they have. That's the idea of using SiteOps. You obtain an incredible increase in production capability as well as a proprietary edge to marketing the services of your organization. All right, so that's where we started. Everything in here is not only linear as it appears right now, but it's also curvilinear. And so if I go ahead and grab that PI and then look at my properties, I can change the radius on that PI, let's say to 500. And so now I'm closely matching the road here. Again, once I generate the conceptual design, I sell this to the client and they're happy with it, I would then obtain a contract for services. And one of the first things I would do is obtain a survey task order. At that point, I would go ahead and survey the property boundary, I would survey the topography, and then use AutoCAD DWG files to import that data into SiteOps. So I would correct this boundary that I've estimated into place with a real boundary. And I would replace the initial topography with real topography, just like on a normal engineering type land development project. Okay, so that's where we are. I've estimated this project boundary very close to what the client showed me they wanted to purchase. And if I go ahead and win the job, I'll survey it into place and then update this file. All right, so let's go ahead and start a design. In Warrenton, Virginia, they used to have Joe Jacoby, one of the Washington Redskins, former Redskin. He had a car dealership, and he lost it during the recession. They went out of business. So this town is ripe for a new car dealership. And what the client is thinking is at this intersection of Route 17 and Lee Street right here, they're both divided highways. This is a great intersection with a high visibility. And if you're going to have a car dealership, this might be the perfect place to put one. We're going to evaluate that. Now, I'm going to go ahead and fade back the picture so I don't need to look at the photo, and I can concentrate on my engineering now. One of the things I'm going to propose is a building that's 200 by 100, and this will be for the new car dealership. Now, I can grab this building. I use my CAD commands in the upper left here to move and rotate wherever I want to go with this thing. These commands are very easy to use. There's only a handful of them. And you'll notice that I can move, I can rotate numerically. If I want to type in an angle, I can do that as well. And so perhaps I'm happy with the location of this right here. Now, in looking at this car dealership, there's a couple of things that I'm just going to speculate and put in here. And one of them might be the square footage. Okay, I want a building height, and I'm going to offer a 3-story building to the new car dealer for various offices, financing, and things like that. In addition to that, we're going to go ahead and put a sidewalk around the building. So you notice in the properties here, we're going to say that it does have a sidewalk. And that sidewalk is 10 feet wide, has a cross slope of between 1% and 2%, and is 4 inches thick of pedestrian concrete. Now with that information, it has a cost for the sidewalk. It already has a cost for the building. It knows the foundation, all based on the presets, and other engineering criteria is also associated with this, such as having a 24-foot drive aisle around the building. Okay. Now, I don't see the sidewalk because I have not turned on the geometry solver. And so on the left side, I've got 3 solvers: the geometry solver, the grading solver, and the piping solver. Let's go ahead and invoke the geometry solver. And of course, you'll see that I have a sidewalk. Now, I'm going to go ahead and generate a parking lot, and the parking lot will be for customers as well as all the new cars out there. And so we're going to surround that building with a parking lot area. And I'm going to put it in a little bit willy-nilly. I could be extremely accurate, but maybe at this stage I just don't need that level of accuracy, because I'm going to let the parking restriction lines guide my parking lot. And as soon as I draw that and close it out, you already have a parking lot designed. Everything is to engineering specification here. 9 by 18, 24-foot drive aisles. All your caps, your islands are all developed. I have raised islands in here because I've told it to raise the islands. Okay, so there you go. Within an instant, you've got a parking lot surrounding this building, And I know I have 904 spaces for the new car inventory as well as the customers. All right, so let's discuss this a little bit. This is a new car dealership, and the client would like to put their daily special cars right in the front of the building. So I'm going to grab that building wall, and I'm going to go ahead and tell it that we have a 24-foot sidewalk here, which is enough room for me to put my cars right in front of the building and put my daily specials on them. In addition to that, I'd like customers to park right in front of those cars. So I'm going to allow parking on that side of the building. Again, as soon as I can envision these changes, I can invoke them and I see the results immediately. Okay. Now, let's investigate that a little bit. If we have a new car dealership, we need to honor the ADA regulations. So I'm going to go ahead and allow for some handicap units right here. So in the parking, I'm going to install 3 handicap spots. So I'm going to tell it 3. And as soon as I indicate that, it already recounted them. I lost a couple of spaces in the parking lot, but I've gained my 3 handicaps. Let's go ahead and add a van accessible. And we'll put that right over here. We'll make that 16 feet wide. Let's go with one of the van accessibles, and we'll say OK to that. And again, I have a recount and I have van accessible. Now, I mentioned earlier that the parking lot grading, if you'll notice on the right, can be as low as 1% and as high as 4%. Maybe on this site, I have quite a bit of terrain here, and the county will allow me to go 5%, so I might do that. You see, I can make changes to all these characteristics. All right, so if the parking lot does go anywhere near 5% at the front of the building, then my handicap spots are in trouble. The ADA regulations on a handicap spot is usually no more than 2%. So what you're going to notice is that when I pick the handicap spot, I can control the slope independent of the parking lot. And of course, I'm not going to let it go to 4%. I'm going to let this one range between 1% and 2%, so I stay within the ADA regulations. On the second handicap, the van accessible, I'm going to go ahead and just for fun, just to let you know, I'm going to lock it down to 1%. Okay, so basically I'm in control of this entire area, both in 2D as well as 3D. Now, on the first go around here, you'll notice that the parking came in almost horizontal, pretty well horizontal. It's actually parallel to that long property line, or sorry, parking lot line right there. But that may not be the ideal configuration for this client. If I wanted to redirect the aisles, instead of going east-west, I'd rather go north and south, then I'm going to tell it that. I'll give a parking direction path, and I'll just send it straight north. And again, as quick as I can say it, it just does it. Now, I've got a couple of dead islands here. I'd like to rectify those. And so this stays alive. You'll notice that. And so I can reconfigure the parking so I have no dead islands. I can also go ahead and rotate this. It all stays alive. And maybe the client wants all the customers as they drive into the parking lot to head toward the building and see the building. Okay? So this is how developers react. They're looking at the customer, the market, and things like that. And they have what appears to be unusual requests sometimes. But our job is to satisfy those requests. And you see I've done that here. Now, if I take that vector out, it'll return back to the default, which just happens to be the longest side that it saw. But we can go beyond this. And so we'll do something that you don't see very often, and that is I'm going to put in a parking direction path that may look something like this. Okay, that's great. Now I'm going to grab that PI right here, and I'm going to crank up the radius on it. All right, and now there you go. We have radial parking. Okay, we have curved parking. And the reason you don't see this very much in land development is because engineers just don't know how to do it with their CAD systems. Now, this object still stays alive, so I can further refine the parking lot. You'll notice I'm changing the radius as we go. I can go from convex to concave. I can go back and forth. I'm in total control of this parking lot. Okay, that's wonderful. Okay, a couple other things we can do. Again, we want to refine this parking lot so it meets all of our standards, county regs, things like that in 2D and 3D. So perhaps I need some sort of a landscaped bay in here. Maybe I'm going to throw a little bioswale, throw a rock garden in here, or I just want a landscaped area for some nice vegetation. So we're going to come over here and we're going to go ahead and put a parking bay in, and I can put it anywhere, and I can put as many of these in here as I like. That parking bay, I'm going to go for an 8-foot median on that. And just so I can show you, I can change the parking angle on that bay. Let's go with a 60-degree angled parking, and I'll even go herringbone on this one, and you'll see I can shape those angles any way I wish. I can also take the entire parking lot and change that to, instead of 90 degrees, we'll change the entire parking lot to 60 degrees. But I can override with the herringbone approach right here if I choose to. I'll go back to 90 degrees there. And so we've made our point. And now this is alive. So if I want to switch bays here, I can change my mind. You'll notice it's alive. Okay, and ultimately I'm happy with that guy. Again, I can put as many of these out here as I like. Now, because of the weird angle of the parking, perhaps the client or the county or maybe I or my boss would like the drive aisle to be wider. And so we can also control that and put a parking lot aisle point anywhere we wish. You'll notice in the properties, I'm going to crank it up from 24 to 36 feet, and now I have a wide aisle here. And again, I can move this anywhere I want, and I can put as many of these out here as I wish, and they all change. Okay, so that's great. All right, I've also got control of the islands. I have overall in mass controls, which you're looking at, these purple islands, but I can also go ahead and put islands of my own in here. And so perhaps I'd like a wider island right here. Instead of a default 9, let's go with a 24-foot island, because maybe I have an old English elm tree I want to transplant right in front of the building as a community highlight. So again, I'm just making this up to put it in context, but these types of things are very real, and what I'm saying does occur on projects. Okay, so there you go. Some parking lot refinement tools. This parking lot should be exactly what I'm looking for. If it's not, just give me 2 more minutes and I'll make it so. Now, I need access to the parking lot. And so I'm going to put an entrance, maybe 1 or 2 entrances into this parking lot, into this business. I'm going to fade the picture up so I can see where the edge of pavement is. And now add an entrance. Okay, I'm using a car drive path, and I'm going to come right off the edge of pavement here. And I can bring this in anywhere I want. And you'll notice I also have snaps to make it accurate. So perpendicular would many times make sense. So we have a perpendicular entrance now. When I look at the properties for that road, I would normally change these in production, so I don't have to change them. However, when I do presentations, I leave certain settings incorrect just to show you that I can correct them. So I don't want a flexible crown on this road. I want a normal standard 2% crown, and there we go. You'll notice that the minimum slope on this entrance will be 1%, maximum 7%. That's usually okay for cars. And that's why we have other paths. Excuse me. We have a truck drive, wider lane, heavier load. Okay, and so we have a lot of tools in here for things like that. But let's summarize where we're at. Okay, if you took all my talking out of this presentation, I don't have more than about 5 minutes worth of work done here. Okay, so that's the reality of it. Within that 5 minutes, I'd like to go ahead and immediately see how feasible this project is. So I'm going to hit the grading button. And it starts to grade the site based on the parameters that I gave it. If I turn the contours on, you'll see them all twinkling. That means they're thinking. They're trying to calculate the cost to be a low-cost scenario, and I'm trying to balance the site. Now you'll notice I've moved 54,000 yards of earth to build this site, but I'll end up with what, maybe 500, 600, 700 yards of export at the most. So I think we can agree that this is a balanced site. If I submit this into the cloud for high-level processing, which is included in the package, I will start to approach zero even better than I am now. I'm processing at the low level, which is the speed at which a laptop or a PC or an Apple product can process. Once you submit these into the cloud for high-level processing, they go onto Sun Spark stations, which can be 100 times quicker than a PC. And so you get a better solution. You get more iterations of the engineering constraints. And so you get a refined solution. Okay. Now, if I turn the boundaries off, you'll see where the cut and fill is occurring. Red is cut, blue is fill. You'll notice that it all occurs around the construction area. It didn't travel a long distance away to get the earth. It found it right in that area. That's good news. Now I'm looking at my project, and I'm running $1.3 or so million I've got a virtually balanced site right here. And so I've moved a lot of earth. My clearing and grubbing is 152,000. My cuts, my excavation, 300. And I have, probably 700,000 in material costs. And there I am within 5 minutes, I know that. Now, one of the things that troubles me a little bit is I've got almost $100,000 of retaining walls. I didn't ask for any of them, but they showed up anyway. So there's two reasons why I might get a retaining wall. The first reason is if it's cheaper to build a wall than it is to grade it out, the software will offer me the wall. Second, if I gave it no choice and it had to put the wall in, then it will put the wall in. And since I'm looking at this site, I can see that that is what happened. Now, for a couple of reasons. Number one, you'll notice and recall that I drew the parking lot right to the extremities of the property. The parking lot goes to the parking restriction lines. I can't go any further legally. In addition to that, if I exaggerate the vertical scale to give you a better view of what's going on, you'll notice what I did here. Without knowing it, I shoved the parking lot right into the side of a hill. So it cannot grade out on either side. You see that? It can't grade out without violating the property. And that's why I got a wall in this case. So now that I know that, within 5 minutes of my starting this project, I have some good ideas on how to fix that, lower the cost, and remove the retaining walls. Watch how we do it. Closing out of the grading, and I'm going to go ahead, and what I'm going to do is grab that parking lot perimeter, which we just sketched in there, and I'm just going to relocate some of those corner points and pull them away from the property line so I can get a little breathing room. And if it can grade out, maybe now I've got the room to grade it out, you see? I'm going to do that on both sides of the project because they're both generating retaining walls. And now I'm giving it a little breathing room here. I want to rectify that road, and so we'll go ahead and rectify that. All right, and I can have a lot of tools on how to do that, and I just grip edited it right there. Okay, so within a couple more seconds, I did a what-if scenario to give the parking lot a little more breathing room. I have a dead island here, and so I don't like that. Let's see if there's some way we can get rid of it. All right, well, there's one way right there. Everything's looking pretty good. And now I'm going to go ahead and regrade the site. So that was it. A couple of seconds worth of work with the knowledge I've gained. And now we're regrading it. What you'll notice, if I leave the contours off, are these little indentations right here in the front of the building. Well, remember the constraints? Those are the handicap spots. They're grading virtually independently at the constraints that I gave it of 1 to 2%, even though the parking lot around it could be something different. It will blend them together so that I met my ADA regulations. All right, now let's take a look at the results. I've got 14,000 yards moved. I have a perfectly balanced site, virtually nothing to import or export. So I've met my criteria there. My contours, great. They're still thinking through it. And what you're going to notice is that I no longer have retaining walls. I've got no retaining walls, and you'll see they're gone. If I turn the contours back on, you'll notice that I've now graded out the difference between the cut and fills here at 3 to 1 on both sides. So I now have the room to grade it at 3 to 1 without encroaching off my property. You see that? Okay, so there we go. My cost came down to the high 8s, and so I can build a new car dealership for about $900,000. And of course, a dealership of that size should generate significant revenue over a 5-year amortization to pay for this very easily. This should be a very profitable site. And the more we design this, I think the more you'll see that. Okay, so we're going to bounce out of the grading. We already know things are looking pretty good here. And if I turn the contours on, there's the proposed contours that we just designed. And I wanted to show you that you're not stuck with these contours. The contours that we've produced are cost effective. We're getting the lowest cost to build this site at. And also within regulation, okay? So perhaps we have alternative gradings in mind. Maybe one of those would be to drain the site in such a way as to sheet flow it. If I sheet float it, maybe I don't need any storm sewers or inlets in this area. Okay? That could drop the cost significantly. So we're going to violate Mother Nature, and we're going to tell the grading to do something that we want it to do. and we're going to check to see if we had a good idea or not. Okay, so we're going to go ahead and add a grading constraint, and I'm going to split the site right in two and put a high ridge right through here. And so I'm going to pick a point right there, come near the building. I don't have to worry about the building. It's flat. It already knows what to do there. So I'm just going to bypass the building on my grading, take it up, bring that high ridge over to the east side, take it all the way to the bottom, and then close that object. So I have a grading constraint area. I'm going to lock it into about a 3% grade and then direct that drainage to the south. Oops, not that one. I'm going to use slope direction. So I have to pick that over again. There we go. And use a slope direction path. And I'm going to drain that, let's say, in this direction right here. And if you zoom in on that, you'll see it's a drainage vector showing the direction of the drainage that I'm desiring. I'm going to repeat that on the north side. Add the grading constraint. And I'm going to snap it into place so that I have good accuracies. I want a nice, tight, high ridge here. Again, I'm going to bypass the building because a flat building is a flat building. I'm going to snap that into this high ridge here. Let's try that again. There we go. And snap that into the other edge of that ridge. Take it up to the north side. And again, I'm real loosey-goosey about this, but I can be in certain cases. All right, now I have this grading area as well. We'll go ahead and we'll lock that down at 3% and see how we can get a sheet flow going here. Slope direction path, I'm going to go ahead and slope that in this northeasterly direction. Great. Now that we have that, I'm going to go ahead and regrade the site. And let's see how this goes. We'll see if we had a good idea or not. Okay, so if I turn my contours on, you'll see that they look nothing like the contours we had before. Now I have a high ridge to the center of the site. I'm draining the south end to the south, and I'm draining the north end toward the north. You can see that very clearly in the contours. I have a little bit more grading here now, but it seems as if I'm okay. No walls are kicking in. I do have enough breathing room here to go ahead and grade that site. You'll notice that my cost went up, about $150,000. So I violated Mother Nature because I had something very important in mind, and that was to sheet flow that site. Well, I did it. But since I violated the Mother Nature scenario, I'm going to pay for that. It's just like running water downhill doesn't cost much, but running the water uphill does. So anytime you buck Mother Nature, you're going to pay for it. And that's what I'm doing right now. I'm bucking Mother Nature, but sometimes you have to do that, and I will pay the price. So that extra $150,000 in grading, perhaps I saved $250,000 in storm drainage and inlets and all the structures. So those are some of the things that we're weighing, and we can certainly use a SiteOps to make those decisions for us. All right, so we're going to go ahead and bounce out of here, back to our site, and I've kind of made my point with regard to the grading constraints. You can change the grading any which way you want, and so there we go. I just took them off. I'm going to regrade the site, and you'll see how these contours that were sheet flowing, they'll now go back to a cost-effective solution. And you'll see right there, I have saved $150,000, and I have normal. These are regularly approved contours. Nothing wrong with the grades on these. They just slope a different direction, and the direction they're sloping is a cost-effective direction right now. Okay. So I can override these and make any decision that I wish, just knowing that I'm going to pay for these decisions, and I can see which decision might cost me the most, and I can make my engineering criteria, based on the cost. All right, so we're going to go ahead and bounce out of the grading. It updates itself right immediately. And so there we go. Let's see. I've got my sidewalk around the building, got my daily special shown here, my handicap units, my parking's in place, it looks good on the grading, and I have plenty more property to buy, to develop. So if we have a new car dealership, it would make sense maybe to have a used car dealership. All right. So let's go ahead and give this manager here a 50 by 50 building. And we'll take that used car dealership right here, and we'll move it into the site. And then we'll surround it with a parking lot and let him put his used cars out here. And I'll give a little bit of a landscaped area between the new and the used. And we'll go ahead and, again, be willy-nilly about this. Generate the parking. There we are. I've got a dead island. I'm going to rectify that. There we go, took care of the dead island. And since I already have the advanced knowledge that there's a hill on the west side, and I don't want to shove this parking lot into the hill, I'm going to go ahead and take the knowledge I have and just give myself some breathing room, just like we saw before. And I want to eliminate those retaining walls. Okay? So what I can learn on a project in just a few minutes, half hour, something like that, will far surpass any knowledge that you'll gain on a CAD system if you're using a CAD system. It would take you days or weeks to understand this project as well as I do right now if you're in just a CAD system. I'm going to go ahead and give parking on all 4 sides of this particular building. We'll say yes, it has a sidewalk, and we have the drive aisle around it. Maybe it looks a little funky, so maybe I want to rotate this building into place, maybe something like that. Okay, so we can do a couple things here. And we can move this building around, like I say, rotate it. Okay, and so if I don't like the funny little islands that I created, I can totally control them. Maybe something like that would look a little more traditional. And I've got all the accuracy commands that I need to make these things parallel, perpendicular, and other things that designers worry about. All right, so we know we can manipulate the heck out of the parking lot right there. I'm going to put a little connecting road between the 2 parking lots, give the customer a nice easy access in and out of that. All right, and we'll do the same types of things here. Let's go ahead and change the values on this. We'll go with a normal crowned road. And again, 7% slope, maximum on that. Okay, so there you go. I spent another 2 or 3 minutes adding a used car lot. Let's regrade the site, and let's see how much it's going to cost to build a new and used car lot. Okay, it's grading away. I moved 27,000 yards of earth, and I'm at $1.4 million. Now I can look at the revenue the used car lot might generate over say a 5-year period, and I've got what, 400,000 to 500,000 invested in adding that new car lot. Okay, so that should pay for itself pretty quickly. I've also eliminated all the retaining walls based on the prior knowledge that I had. Okay, there we go. And all of that within, say, about 10 or 15 minutes. If you took my talking away from this, I probably don't have more than 10 or 15 minutes worth of work. All right, so we have this much of it, and maybe I'd like to see, can I drain the site? And if I can, then I've met my grading constraints. If I can meet my stormwater constraints, this becomes a very, very desirable site. All I'm going to do is press the piping solver. And there we go. I'll turn off the contours so we can see the piping, and you'll notice that it found the low spot on the site. And it's basically just dumping the water at that location. Perhaps it's a ditch or something like that. So I'm in control of this as well. What I want to point out is that we have white pipes and white inlets. And that means several things. At this level of design, we just learned a lot about this site. Okay, here we go. Number 1, I have no standing water on the site. Every piece of that site is now drained. And that's why you see so many inlets out here. Again, we're at the low-level solver, and we're using everything that the PC, laptop, or Apple can give us. However, we still don't have perfect surfaces. We have surfaces that are very good, certainly ADA reg and all that type of stuff. But if I submit this into the cloud, I'll get even better surfaces. And as a result, 3/4 of these inlets, typically in my experience, will disappear. I won't need them because the surface won't have any sags in it. Remember, I said we have drained the site. I have no standing water. And I have a little bit of pocket, a little bit of sag in here because of the grading design at the low level. Submitting to the cloud takes care of that. So number 1, I have no standing water on the site. So yes, I can drain it. Number 2, I've met all my cover conditions. I have a default in the constraint saying that I want a 3-foot cover on all my piping. Anytime I see white pipes means I've achieved that. Third, if I zoom in, I have met minimum slope calculations on the pipes. I told the software I don't want any pipes less than 0.5%, and you'll notice that I've achieved that. Okay. And then the last thing that it's done is it's sized the pipes. Okay, 24-inch pipe, 12-inch pipe, 18-inch. So you're getting something that's fairly reasonable and is hydraulically correct. Now, if we continue to look north, it even put a clean-out manhole, since once I exceed about 300 feet or so, I need an intermediary manhole for maintenance. It already put that in for me. Okay, so there we go. My site is feasible. Well, let's look at it. I have a grading not feasible. Let's see what caused that. And let's look at the problem layer. And it's a very minor detail. This happens sometimes quite often when you start an entrance in a rural or suburban type area where you have ditches on the roads. I put this point to start my road right on the edge of the pavement here. Okay? And so very likely I put that point on a ditch that's there naturally, not naturally, but in existing ground. Okay, now remember, this profile can only go to 7% max. And so I'm in trouble right at the start point where the ditch is at 3-to-1 or 33%. My road can only go 7. And that's why it's telling me I've got a little issue right here. You see that? And so we can rectify that many times by just shifting this to another triangle. All right, move it over here perhaps, and I come in or out. There's a lot of ways to rectify this. And so I just moved it a hair, and I'm going to try to regrade it and see if that took care of it or not. Okay, again, you only need to let this run for about 7 or 8 seconds, and it does the best bang for the buck in calculation at that point. You can leave it here further. The numbers will get better, but it's like diminishing returns. The more time that goes by, the less it's actually reducing costs. It's already done the bulk of the work. Okay, so 7 or 8 seconds, really all you have to sit here. You can close that out at that point, and you'll notice, whoops, do I still have the same issue? I do. And so I'm just going to maybe relocate that. Let's turn that problem off. I'm going to relocate that road over a little bit. Okay, so I want to find a nice optimal position. So I want to grab this guy. And I don't know why I'm having an issue there. Okay, so we got that. And we're going to take that driveway point and move him over. Okay, so I'm just relocating the road a little bit. Okay, with some residual graphics there. And I'm going to try to regrade it now. Let's see if that took care of it. Again, these are details. On the overall perspective, that little grading issue has nothing to do with the project. All right, I'm going to just let it go for about 7 or 8 seconds. Oh my goodness. Again, you can see I'm doing this live. And so again, I have another issue, so I'm going to try to pull him back. Oops, let's go over here. And I don't want to see those triangles. So I'm going to try to pull it out of that ditch again, and let's regrade it. Okay, so everything you are seeing here is live. This is not a canned presentation. I am recording it as I go, though, but I'm doing it live. All right. Again, all my numbers are looking good. Everything's in place. Try to close that out. And oh my goodness, what a pain in the neck that is. Okay, so the same issue. I'll come back to this after I refine my site a little bit. Okay, so there we go. We know we have a good new car dealership. I've got a connecting road, and we have a used car dealership. Let's explore the road design for a moment here. And I'm going to go ahead and draw a road off this north-south Route 17. And we'll go ahead and put another car drive path. I'm just going to pull right off of that, pull an entrance in here, and tie it into the used car lot. And the idea here, sometimes, not only will the software show us what we can do, it'll also show us what you cannot do. And so in this case here, what I'm going to do is use a roadway template. Let's go ahead and give a minimum radius of 120 on this guy. So I'm changing the radii. I'm going to use K values. We'll throw in a 40 K value here for the crest and the sag vertical curves. I'm in control of all these types of things. Great. Now let's go to the template, and I can store and create any number of templates in here and then use them as I wish. So if I want to go ahead and put a median divided roadway as my entrance in here, I'm going to pull it out of the cloud. I can make any changes to these parameters, as you can see, and go ahead and apply that. And as I do, you'll notice that I now have a median in the middle, and I've got sidewalks on the edges, and everything's looking real good here. So I'm going to go ahead and regrade this site. Again, I'm limited to a 7% profile, max profile on here. And so what you're going to see in a moment is that could be trouble for me. You'll just notice one thing, the whole site dropped down a bit. Other than that, it looks somewhat reasonable. But I'm noticing some issues. The site is under stress. And so I'm wondering why. Okay. Well, I'll tell you why. I'm going to exaggerate the vertical scale and then come over where that road is, and you'll see that the road became my limiting factor. There's so much grade on this road coming up to this parking lot, I'm limited to 7%. And so it dragged the entire site down. And look at my costs up to $4 million. So immediately I can see this is not a feasible place to put a road. So within a couple of seconds, I learned what not to do. Don't put a road in here like this. Find another way. Otherwise, I'm going to pay dearly, and that just doesn't make sense. Okay? So SiteOps will show you what you can do. It'll also show you what you cannot do. Take that out. Let's look at the problem layer here, and you'll see the entire site is under stress now. Okay, so that's not good. And it all happened when I put that additional road in. So I'm going to go ahead and take that out. That's a non-feasible situation. And there we go. So I've got to find another way to get in and out of this this project. Okay, and that's what I've learned. That's wonderful. I'm going to regrade the site now. Take that road out of it. And you'll see it's looking much better now. It didn't sink the project. My costs are back in place. And like I said, I learned what not to do within a couple of seconds. Now, if you were in a CAD system trying to do this, you would have had to lay out a horizontal, a vertical, cross-sectional templates, design it. Oh my goodness, you'd be there, maybe for hours, and then you'd find out you couldn't do it. So you just lost all that billable time. Okay, well, I learned it within a minute or two. And again, that's the power of the SiteOps. What if scenarios? Okay, so we know we can drain the site. We did that, and that looked pretty good to us. Maybe I'd like to control the drainage now and put a pond in. So let's go to the stormwater tools, and I'm going to go ahead and estimate a pond in this upper corner because I know this is the low spot. I learned that on the first drainage exercise that we just did. And so when I draw this pond, I'm in control of it. So I can control the heights of the ponds, the risers, things like that. Dry storage height, the riser height. I'm in control of the elevation, so I control this pond right now. And one of the things that I find interesting is that at the conceptual level, I'm going to tell the software to use the pre- and post-developed rainfall quantities and land use and size the pond for me. So I'm going to say size the pond. And you'll notice it's a lot less than I originally thought. So I can recover this land, push that pond to the corner, and then sell this extra space that I would have lost or potentially lost. Okay, so there we go. Now, I want to grade the site so it sees the pond. And again, we're only going to let it go for about 7 or 8 seconds. Now it sees the pond up here in the corner. And everything else is looking good. So the pond didn't cost very much. Alrighty. Now that we have a new grading plan, let's hit the piping solver and let's see if we can still drain the site appropriately. And indeed we can. What I'm looking for are white pipes. Again, that means I have drained the site. There is no standing water. I met all cover conditions. I met minimum pipe slopes on my pipes. I've sized my pipes and added in intermediary clean out manholes and things like that. Again, don't get concerned with the number of inlets here. These are only because I'm at the low level. And that's why I don't get a cost for the drainage at this point. We all know that the costs are not real. However, I'm looking at feasibility. Can I drain it? Well, I now know that I can. I'll submit this to the high level. 3/4 of those inlets will disappear. I'll get a much more realistic drainage plan, and I'll now get a cost for that. Okay? At that point, you can move the project, if you wish, into a CAD system and go to final design. Okay? So at that point, different counties have different regulations, and you would then go to your normal pipe design and pond design criteria for that county. But the good news is if you can use a rational method to get this far with the pond sizing and the pipe sizing, then your normal county methods will also work. The rational method is a very conservative method, and so this is like the worst case scenario. And if you go to final design, you can improve this with your local county regs, and you should have no problems if you can do it at the rational level. Okay, so there we go. We know we can drain the site. We know we can grade it. I'm going to go ahead and turn off the piping here. By doing that, I'm just going to regrade it. That'll take the piping off until I do it again. And there we go. All right. So again, I've got my little, let's see where he shows up now. Well, it's the same spot. There's couple of little square feet of area right here. And now I shouldn't probably waste your time in the demo to do this, but this is just bothering me now. Normally this is not a difficult situation. Let's go ahead and turn him on. Now it's just challenged me. That's the only issue that I'm at. So let's see. I want to go ahead and kind of drag this guy, and I don't want that to happen. Alrighty. So let's just drag him over. Let's drag him over. I'm just relocating him. You see that? And I'll pull him again. There's a ditch here that's killing me, and so I'm going to try to get him out of there. All right, so he's updated on the solver. Let's try to grade it. Let's see if we can get rid of that little problem. Again, this is not an issue. I could go to Final Design and completely just blow through that and handle it later if I wanted. All right. So designing away, there's our contours. Got a nice little crowned road coming in as an entrance there. Everything else is looking good. My costs are good. My balance is perfect. I'm going to close out. Let's see. I still haven't gotten. Now I'm really upset. So anyway, we'll get rid of that here in a few minutes. Let's continue on with our design. And that could include, perhaps, if I have enough room here, maybe I'd like to go ahead and develop a few housing lots. So maybe some single-family units I can put in here. In Warrenton, they're going to run at least $300,000 for a house. And so if the developer wanted to add a little housing system back here, a little parcel system, let's go ahead and do it. See if we can add some more revenue to this project. So I'm going to go ahead and put some parceling out here, and I'll just allocate this area from here to here. I'll cut around the pond. We'll leave that in there. We'll call that waterfront property. And we'll come in here, and then we have a parceling area. If you look on the right side, you'll see the properties for the parcels. I'm in control of them. So maybe I'll go with 120-foot parcel depth. I'm looking for a moderate-sized parcel at 10,000 square feet. I could type anything I wanted in here. I've got all the setbacks that the county might want, front, back, and side. I will put buildings in here, and I can play with those. I'm in charge of the grading on the subdivision. Let's go ahead and we'll allow it to go to 15% since I do know I have some terrain here. And you see other things for storm piping and runoff coefficients. All right. So at this point, let's go ahead and see how many parcels we can generate and sell for $300,000 perhaps. To do that, I'm just simply going to draw the streets. And so maybe I'm going to come off this little side street right here, and we'll just take there, we'll drag it right in here and terminate. Turn on that solver, and there we go. So, all right, now maybe I'll throw a cul-de-sac in here. So I'm going to grab that endpoint, go to the properties, and let's go for a 40-foot cul-de-sac. And I can see I'm under stress there, so I'm going to pull it back, and maybe that's what I want to do. Okay, maybe we'll just see how we can drag it. We can maximize exactly how many. I'm going to take the beginning here. Maybe we'll drag him down a little bit. See how we're maximizing the use of that parcel. Come in here, again, drag it, maximize the use of that thing. Again, I've met all my statistics on this parceling area. Now, I'm just wondering if I can add an extra little side road and put maybe something up here. So let's try it. That's what we're doing. What if? So I'm going to come off of that little street here, maybe come in here and try to put some sort of cul-de-sac in there. And let's see if I can do it. So within a few minutes, you'll notice that I can maximize how many parcels can fit on this parcel. All right, and it looks like this is going to be a pretty tight area here, so it's probably not a very good place for me to do that. And so I'm going to bail out at that point. I've learned probably this is not a good thing to do. All right, okay, so there we go. We've got 11 parcels, so we just made $3 million. If I sold those for $300,000 a piece, there you go. So we've just added some more revenue. And so now we have a new car dealership, used car dealership, got some parceling going on back here, and maybe I have room for enough for a landscaped area, a little park back here. Okay, let's go ahead and grade the whole site, including the subdivision now. And you see the subdivision grading away back here. Okay. That's wonderful. Contours. All right, and that's long enough. We'll say okay to that. And let's see, do I still have my little challenging spot? Yep. Other than that, the site is perfectly good. It's just right at that entrance on that little ditch that shows up right here. And so, again, I'm challenged by that, but I don't want to waste time in the demo. I'm just annoyed right now. All right, so let's see what else we want to do. Okay, so I've got some information. I got a geotech report, and the geotech report indicates that I could have subsurface rock affecting my design. So yes, we can address subsurface conditions. I can sink borings, core holes into the project. So I'm going to go ahead and sink a core hole right here, and using the geotech report, I notice that the rock depth is only 2 feet deep here. I've only got 2 feet of overburden on top of that rock. All right. Let's go ahead and add some more. We'll just add a couple in here just to make the point. The core hole here is going to be 4 feet deep until I hit rock. Let's go ahead and add another one up here, and I'm just making things up right now, but let's go 5 feet because that's what the geotech report said. And let's go, we'll do 1 or 2 more. And let's see, there we go. Rock depth. Okay, where is that guy? Borings. There we go. Rock depth, let's say 7 feet at this point. And as I continue to go north, I get a little more overburden each time. All right, so I got 8 feet of depth there. Now, I've sunk 3 or 4 or 5 core holes in here. These can be exactly placed into place, not by eye like I did it. And so now we're wondering, does the rock impact our project? Okay, let's go ahead and regrade the site. And it's starting to grade out. Okay, let's see. Turn on my contours. They're still there. Everything's looking good. My cost did go up, though. And one of the reasons is because I've got 2,000 yards of rock cut that has to be removed off the site in order for me to design this effectively. See that? So I've got 1,900 yards of rock. There is a cost to removing it, and that's why I have export here right now. And so the question really is, where does the rock impact me? And so I'm going to change my view to a pre-graded rock scenario. So before I cut the rock out, where does it show up? All right, well, it's not too bad. It's actually in the pond. Okay, so it's not too bad. Now, if the rock showed up here in the southwest corner, perhaps I'd redesign this parking lot to try to avoid the rock, you see? That's why this is so beneficial. I know where the rock is going to impact me, and I might be able to just move the parking lot or reshape it to avoid the rock, and then save, $200,000 or $300,000. So right now the rock isn't really impacting me too much. Maybe I can make the pond shallower and more area. So if I can increase the area of that pond and make it shallow, maybe I can avoid that rock. You see? So these are all conditions that I'm learning in the software within a few minutes, and there we go. Okay, so yeah, rock does impact me. Again, do I have my little annoying guy? Yeah, sure do. So other than that, no issues. This is a very minor issue. Other than that, the entire site is perfectly fine. Now, in addition to being able to investigate rock, you also might find that the geotech report has identified some unsuitable areas. And so we've identified that maybe in this area right here, and again, I can draw this accurately, and I'm just doing it quickly for the presentation. I now have an area of unsuitableness, and I'm going to go ahead and tell how deep it's unsuitable. Okay, so the unsuitable depth, we'll say, is 3 feet. Okay, so, but I'm not limited to a flat area. I could go ahead and take this point on the geotech report and say, oh, it's 5 feet here. So I have 3, 3, 3, and 5, you see? So I can manipulate this any way I really need to. Now, the idea here is that if it's unsuitable soil, it needs to be removed off the site. So it's going to have to cut down 3, 4, or 5 feet there to collect that unsuitable soil and then remove it off site, and there's a cost for that. But that leaves us with a big hole, and so the software knows that it has to backfill the hole, and then it has to put materials right on top because I've also encroached on 2 of the parking lots here, and so it's going to dig the hole out and remove it at a cost, backfill it in again, and then lay the parking lot materials on top. This is a very, very heady calculation, all being done within a matter of seconds. Now, let's see if the unsuitable area affects us. I'm going to go ahead and regrade the site. All right, and there we go. We're grading it. Yes, the cost went up fairly significantly because I'm having to remove 22,000 yards of unsuitable soil. And so now that's why my export just jumped. You'll notice my cost went up several $100,000 as well. So that's what's going on here. And I know this within 15, 20 minutes of starting the project, that this unsuitable soil is definitely going to affect me. And if the cost is that high, maybe we don't recommend this site for purchase. Maybe it's just got too much unsuitable soils on it, So there we go. That's what we've learned. So we'll close that out. Okay, so just in summary here, we were able to take this entire project, and in roughly 20 minutes or so, we laid out several concept designs. We have cost estimates on the project. We have some drainage considerations, parking lots, buildings, roads, residential areas, storm sewers, and all that. We were able to look at subsurface conditions and unsuitable soils. There are a lot of other commands in the software that will help you further refine your design. And we'll do one quick example just to give you an idea of how well this can be used for marketing. They have a tool here. It's called blocks. And I'm going to go ahead. I can create these blocks myself. And I'm going to use this one here called a simple house. The idea behind this is that these are pre-rendered structures that you can lay on your site for shopping malls or residential areas. I even did one with the Alamo on it, just for fun. And so the idea is that I'm going to bring this out of the cloud because I can store them in the cloud. I'm now going to assign that particular house to these houses in my subdivision. So I'm going to assign that building block to this area and use that block. All right, now I'm going to regrade the site. And you won't see anything here. Right now it's still just grading the site, but it's embedding that little rendered block into those house pads. Okay. Again, I only need to go a few seconds here. All right, there we go. And now one of the things you'll notice is that I was able to take care of my little grading issue on that little entrance, and all I did was move him over a little bit. Okay. So again, happens quite often when I put a 7% slope into a 3-to-1 ditch. So I just need to move the point over a little bit. Now that I have that, I'm going to go ahead and delete this guy. I don't need him here anymore. He's already embedded in the project. And the idea now is to go to a presentation mode. And so what I'm going to do is I'm going to kick this into a Trimble SketchUp, which is a rendering device and a presentation device. You'll also notice that if you have Civil 3D and you use it for final design, you can kick the entire SiteOps project into Civil 3D. Now the real benefit here is that everything that you see comes across and everything you don't see comes across. So such things as the pipelines and structures that we saw, they come across as objects in Civil 3D. All the surfaces, and there are up to 4 of them, come across in Civil 3D as pre-built surfaces. The only thing you would do is drop a style on it and then move ahead. There's also compatibility for Bentley products, Geopack and Inroads. So these are direct links. All you do is pick it and sit back, and so that's what we're going to do. I'm going to go ahead and launch the SketchUp, include the blocks in here. Here's my 4 surfaces that I can kick over. Right now I only want to use a proposed finished grade. So I'm going to say OK, and it's going to go find the SketchUp on my system. This is free, by the way. So I'm going to go ahead and start using SketchUp, and it brings it in. You see it coming in right now. So as soon as I get control of the job, you'll see the data come in. And there we go. All right, let's try to fit that on the screen here. Let's see that. Okay. All right, now, if I rotate the site around, everything you saw comes in, right? Including my subdivision over here. You see, it's all pre-rendered, looking lovely. This would be a great little client presentation. I've got a lot of control I can do on this. I'll bring in pre-rendered cinemas and shopping malls and different things like that. So the idea here now is to use this as our presentation tool. Okay, we're going to come over there. Let's just pan him here, and I want to make this a little more human, I guess. And so I'm going to use some of the tools in here, some of these components, and maybe we're going to put some cars in the parking lot. See that? And so just to bring it home, make it look a little more realistic. And I'll come down here. Let's put some landscaping in here on these islands. That was the idea of having them in the first place. And so I drop landscaping, maybe have some delivery vehicles around. And so you get the idea. I can make this a little more human and show this either live or plot it out on a 24 by 36 full color drawing to put up on the wall during the presentation. And you can certainly get the idea across. All right. Now this SketchUp can be round-tripped back to SiteOps if you'd like to go ahead and add the cost for those extra appurtenances that you've done. So there you go. There's a quick overview of SiteOps software for conceptual design. It'll take a project from nothing to about first submission in 8 hours or less, and I've got the projects to prove it. And again, in that 8 hours, it's very likely that you'll have multiple alternatives. Submit those to the cloud for high-level processing, and get your results and make your recommendations. So, thank you very much. I'm Harry Ward, Harken-Reidar.